Hey guys, welcome to this session on how to build a machine learning classifier in Python with Scikit Learn. So in this session, we'll take a look at what machine learning is and how you can use Scikit Learn, which is one of the most popular libraries in Python for machine learning models, to use Scikit Learn package to build models that could classify the data that we send to it. So without further ado, let's take a look at the agenda for the session. So in this session, we'll firstly begin by taking a look at what is machine learning. We'll understand the basics of machine learning. We're assuming that you guys are completely new and have basic understanding of Python, but have no idea what machine learning is. So we'll try and give you some basis to understand what machine learning is, and from there on we'll build on top of it. We'll try and understand different types of machine learning. We'll try and understand what are the kinds of machine learning systems that we can build and what classification could be used on them. Then we'll take a look at what is classification. Since we're going to be building a classification model, it's important to wrap our head around what classification actually is or what it actually means. So that we'll take a look at some of the most common classification problems so that you can understand what classification problems are and how machine learning helps us solve it. Then we'll take a look at what is Scikit-learn, which is the library that we'll be focusing on this session. We'll take a look at why you should use Scikit-learn. And with that, we'll take a look at steps in building a Scikit-learn machine learning classifier. Now, if you're trying to build a machine learning classifier using Scikit-learn, there are a few steps that you need to follow, and those steps are going to remain constant whether or not you're building logistic regression or any other kind of Scikit-learn model. And then finally, we'll top it off with a demo. So let's take a look at the first thing. We'll begin by taking a look at what is machine learning. So machine learning is a fairly loaded term. Many people use machine learning to mean a lot of different things. So in this session, what we'll be doing is we'll first try and understand what machine learning is, because that is the basis of the concepts that we'll be building things on. So machine learning is the branch of computer science that deals with using data and mathematics to help computers learn rather than being explicitly programmed. Now, this is like the quintessential machine learning definition. So to help understand it better, let's first understand what the traditional programming model is. So machine learning has helped developers build tools and systems that could not have built by using traditional programming models. So the reason why traditional programming models don't work is because we would explicitly have to come up with rules and put them in our system. So to give you an example, if I were to ask you to create a machine learning, not machine learning, but create a system that would, using traditional programming models, recognize what a particular image, what is the digit that is contained inside a particular image. Does it contain a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? Now, using that, you could probably define some constraint that the image needs to be 8 by 8 pixels. It could only contain black and white. But even with all those constraints, the variation is so much that it becomes really, really, really difficult for us to use traditional programming models to hard code some of the rules that will take in an image and will spit out the correct answer. So to give you an example, if I were to give you a quick understanding of how this works, you would have to take the entire image, then take the data on each pixel and use that data somehow to understand what exactly is the number inside this image. That is really difficult to do using traditional programming models. While traditional programming models are good for several things, including building applications that could respond to particular events, particular data streams, and a lot of other things, they're not good at changing with the requirements at the pace machine learning allows them to. So for instance, if I were to use machine learning, then our computers can actually generate some statistical models that will specify how confident it is that it is one of the following numbers from 0 to 9, which is a single digit number, which is the problem that we're trying to solve, and it will solve it quite easily. So that's why we use machine learning. It allows developers to build programs that traditional programming models couldn't. In traditional programming models, we would take in the data, run it through the entire program, in which we will use data transformation and if-else statements and many other programming constructs. And using those, we'll figure out what the user wants and give them the output. While in machine learning models, what we do is we take an algorithm, machine learning algorithm, we take some data and we create a model, which then will take in the data and fit out the output. So it's machine learning on its own the rules instead of us having to explicitly type out what the rules should be. So we'll take a look at types of machine learning. So there are three kinds of machine learning algorithms available, or three broad categories in which machine learning algorithms can be divided. These categories are divided based on the criteria of what kind of data we give them and how they learn and what kind of problems they solve. So the first one is supervised learning. So if you take a look at supervised learning, it basically means that we take supervised learning is used to help machines learn how to map input to output based on the input output pairs that we have given to them as examples. So to give you an idea of what supervised learning is, in supervised learning, we give machine learning algorithms some data. That data already has the x variables and the y variables. Now, x variables are the things that the machine learning model expects to be fed into it, and the y variable is the thing that we're trying to predict. So, to give you an example, if you're trying to build a model that could predict the temperature of the upcoming 7 days, let's say upcoming week, then the x variable would be the conditions that you're feeding into the data, and these could be several different things. That really depends on how you're training the model. So for an example, if you're trying to train a model, help try and understand what are the different kinds of things that can affect temperature. So for instance, the altitude of the place that you're at, what was the temperature previous days, how were the weather conditions, what's the atmospheric pressure, and all these kinds of things. These are all combined into a row, and that row is called the x variable. And when we make a prediction on it, it will give us a temperature, which could be in Celsius or Fahrenheit, depending on how you've trained the model. If you've trained the model with the Celsius data, it can't predict Fahrenheit. You would have to convert it yourself. And if you have trained it in Fahrenheit, it can't predict Celsius. You would have to convert that yourself. So basically, in supervised learning, what we do is we give machines some data in which the input and output are already present. The machine learning model then has to take a look at the data and understand how the input relates to the output, come up with the rules on its own, so that when we feed in new data, it's able to predict the output, or at least predict it close enough. So a good example of this would be if we show machine learning, for instance, when we're learning how to read alphabets, the first thing that they do is they show us a lot of alphabets, how to write it. And so after this, we have unsupervised learning. And unsupervised learning is quite easy to understand as well. Unsupervised learning is a machine learning technique which allows a model to work on its own to discover patterns and information that was previously undetected. To give you a bit of context here, in unsupervised learning, let's say that you have been given a lot of customer data, how customers have interacted with your websites, and how, let's say you have an e-commerce website, and how many customers have bought what kind of things, and what are the kind of things that they bought together. So some customers may have bought shirts and pants together. Some customers may have bought gaming consoles and games together, these kinds of things. So what were these kinds of things that they bought together? And then after learning that, you could come up with a strategy on creating offers. So if you are building that kind of a model that can just take a look at the data and then figure out some sort of pattern that's inside it, the data that you're giving doesn't contain the data, doesn't contain the pattern that you want it to find out. That's the main difference between supervised and unsupervised learning. In supervised learning, we give it all the data and all the outputs that we need from the data, and it essentially works out a pattern to map the input from the output. In unsupervised learning, we just give it a lot of data and just tell it, okay, figure out some pattern that could help me out in building my business strategy, or creating or understanding how the data works and how the trends are going, and that way you can use that. So now what we have to do is, after unsupervised learning, let's take a look at an example of unsupervised learning algorithm. So for instance, just like I've told you, you can build a model that can help you generate offers. You can also build models that can help you group customers. So for instance, given a customer and his buying habits, you can group them into premium customers. You can group them into customers that you could follow up on to share exciting offers with, or share reward points or something like that. So that also helps you out in case you're using machine learning. Then comes reinforcement learning. Now this is quite an important kind of a thing. In reinforcement learning, what we're doing is we're teaching our models how to make decisions. Now these techniques allow they use an agent, and what it does is that it takes a look at a machine learning algorithm. It takes a look at the data set, then it tries to create a decision for it, and every time it makes a wrong decision, a penalty is introduced, and whenever it makes a right decision, the penalty is decreased. Okay, someone has asked, do we also have data and reinforcement learning just as we have supervised and unsupervised learning to train our machine? Yes, we do have data. So many different kinds of data can be there. So you could also use reinforcement learning to train a robot. So for instance, whenever we're trying to create a robotic interface, we're trying to create a robot that can take decisions, that can go someplace and do something, reinforcement learning takes into place. So what it does is that it takes a look at the data, that how a person moves, how a person interacts, and understands how to move according to that. After that, what it does is that it takes a look at, okay, what are the different situations and how does a person move in those. If the road is wet, how does a person move? If the road is not wet, it's quite dry, then how does a person move? If the road is slippery, how the person moves. And using that, if the agent that's supervising the reinforcement learning algorithm figures out that the robot is deviating from the way it's supposed to move, it incurs a penalty, and the model is supposed to decrease the penalty, so it tries to not repeat the problems that happened before. uh, all right, so let's take a look at uh, the next topic, but before we do, since I have told you that we have a particular since I've told you that this is an interactive session, I have a question for you. So in a moment, you guys will be able to see a poll, and I'd like you to answer those polls. All right? All right. I've launched a poll, and I would like you to guys to answer the questions. I can see the results coming in, so don't worry. Just keep answering the question, even if it's wrong. It's totally fine. It doesn't really matter. I'd like you to keep answering the poll so that we can understand what it actually is that you guys have understood from the thing that we have understand. So just keep answering the polls. Don't worry about it. It'll be fine. Okay. So I've gotten the answer. 42% of the people have said reinforcement learning. The question for those of you who have not seen the question is, what type of machine learning is used by systems that can play games, that can learn how to play games? So a very good example of this is the AlphaGo that was created by DeepMind, which is a company owned by Google, and it beat the world champion. Out of 4 rounds, it won the 3 rounds of 3 rounds from it. So that kind of system is built using reinforcement learning. So majority of people has answered reinforcement learning. Now they do use some supervised learning concepts inside with reinforcement learning. So you're right there as well. So those of you who have answered reinforcement learning are completely right. Those of you who have answered supervised learning, you are close, but you're not correct. And unsupervised learning is just not the right answer. So with that, let's continue with the session. All right. So now let's move ahead. So now let's take a look at what is classification, because that is the kind of model that we'll be building. I'd like to help you understand what classification is. For those of you who are unaware, classification is a machine learning technique that comes under the supervised learning technique. In supervised learning technique, um, you can build regression models as well as classification models, and we'll be taking a look at classification. I'll also explain what regression is. So let's take a look at what is classification. So in machine learning, classification is simply an activity that consists of putting things into the categories based on the similarities or common criteria. If I give you a lot of people who have applied for the loan, who have applied, if you're working in a banking industry, you need to help understand them. What are the kinds of transactions that could lead to fraudulent transactions? And to do that, you can take in some data about the transaction, the date, the time, the username, the user's credit score, so on and so forth. And using that, you can figure out whether or not this transaction is fraudulent or not. So that is the classification problem, when you already have some categories defined and you want to place the incoming data into one of the categories. So there are a fixed set of outputs that your input can map into. So for instance, our digit recognition is a classic example of classification, in which what we do is we take in an image, we analyze it, and we figure out whether or not it contains which number does it contain from 0 to 9. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, any one of those. So there are 10 possible classes that our input could go into, and that's what we do in classification. So that's what classification is. Another problem could be regression. Regression is basically when you're trying to predict a continuous value. So think of it this way: when you're trying to predict a continuous value, um, a continuous value would be you're trying to predict the temperature, you're trying to predict the housing price based on the features that you have, you're trying to predict the stock market price. These are continuous values because it could be a number in fraction, it could be a whole number, it could be a lot of things. There's no particular categories that you can put this into. So that's regression, and we're learning classification here. So that's the difference between those. So let's take a look at common classification problems. The first is character recognition. So if I give you if you've used anything like Google Lens, you probably know what character recognition is, in which it takes a look at an image and figures out what are the things that are written in that image. So it could be that it figures out what's written on a board, it could be it figure out what's written on a piece of paper, so on and so forth. That's character recognition. Then comes face detection. So if you are unaware of what face detection is, if you ever used a mobile phone with a camera, you put up someone's face in that camera and it creates a bounding box around it to help it focus on the person's face, and that's what face detection is. Face detection and face recognition are two different things. Face recognition is understanding who that person is. So in face recognition, what we do is, good example of it is that is the feature that Facebook has deployed, in which you upload an image and it understands whose face is in these images and then gives you the person's name around the bounding box and tags them automatically. So that's face recognition. This is face detection. Then comes fraud detection. So if you work in the banking industry, fraud detection is something that is used. Fraud detection is something in which machine learning is used quite a lot. It takes a look at a lot of transaction, users' credit scores, so on and so forth, and understands what are the different transactions that could be considered fraudulent. Finally, we have intrusion detection. This is used in cybersecurity. What they do is they take a look at a lot of logs that it has and takes a look at the activity that was performed by particular IP addresses or a range of IP addresses in those logs, and understands what are the IP addresses that have tried to intrude in our system. And if it looks like a person, if it's classified as a person who's trying to intrude in our system, we blacklist their IP addresses, we report them to the authorities. That's the kind of thing that we do. Yeah, so someone has asked, how do we use machine learning in this aspect? Are we using Jupyter in the aforementioned uses of machine learning? So Jupyter Notebook is a software that we'll be using, but machine learning statements don't really care about how you're creating those. Jupyter Notebook is really useful because it allows us to bundle up code with explanations and the output of the code all in one place. So that's why we use that. But if you were to use plain Python scripts, that would work fine as well. All right, so now we'll move on to the next section, in which we'll take a look at some popular classification algorithms. First one is logistic regression. So in logistic regression, we learn from the data, and with that we use a log loss function, and we try and make a prediction about the probability of some particular data point being in one of the following categories that we have. So for instance, in our digit recognition example, what we do is we have 10 different categories, and what logistic regression would do is it would take a look at all the data points that we have given it and figures out a probability that each data point belongs to one of the following categories. So for instance, if I give it an image that contains 7, it will pick a probability of, let's say, around 0.05 that it's 1, 0.4 it's 2, 0.3 it's 3, and it goes along so much. And finally, when we go to 7, it has given the probability of 0.9, which is the highest, which means that logistic regression algorithms give us a bunch of probabilities, and the one with the highest probability is the one that we should choose. So that's the basics of it, and that's how it makes the prediction. Okay, so now let's take a look at the other one, which is decision tree. In decision tree, it's very easy to conceptualize. What it does is that it takes a look at the data that we have, figures out columns and values on in those columns and tries to split the data on that. So if I give you, let's say I give you the temperature. I want to figure out whether or not tomorrow it's going to rain or not. So it's going to be classified as either rainy or sunny. In that scenario, we give it the data, it takes a look at the data and figures out what are the different category what are the different columns that we have or the features that we have, and using those features how can we split the data so that we can make the decisions better. So for instance, if it takes a look at the temperature previous days and then figures out whether, okay, so in the previous days the temperature was 37 degrees. So on 37 degrees, whether if it's higher than 37 degrees, then it takes a look at other features. And if it's lower than 37 degrees, it takes a look at some other features. And doing that, after looking at all the features and coming up with these rules, it figures out, okay, the final answer that I can give you is yes, it's going to rain, or yes, it's going to be sunny. So then we go to random forest, and the random forest uses multiple decision trees to increase the accuracy of the decision. And after getting the results from all the decision trees, the result that has the highest frequency in the decisions that it is gotten from the decision tree is the one that's chosen. So if we get 5 decision trees, and all out of 5 of those, 3 of them predict that the number inside an image is 7, and others predict the number inside an image is 1. 7 is the output that's given to us. And then comes naive Bayes or naive Bayes, however you pronounce it. It's the kind of algorithm that is used by using a probabilistic model. Inside naive Bayes, what we do is we take a look at the probability of something being mapping to a particular class. It comes up with probabilistic heuristics and then tries to figure out how to use those probabilistic measures to use it. Now, in case you didn't understand a lot of these algorithms, it's fine. These algorithms do take a lot of time to digest, to understand, to implement. And as you can see that it could take you a lot of time to understand these algorithms as well as to write these algorithms. It could be very difficult for you. So keeping that in mind, we use Scikit Learn because it contains all these algorithms pre-written for you. So you could just take the data, use these algorithms that have already been built for you, and then figure out what's the accuracy and how well it predicts your data. So now we finally come to Scikit Learn. So what is Scikit Learn? Scikit Learn is a free open source machine learning library that contains generic implementation of common machine learning algorithms. So as we've already discussed, there are a lot of algorithms that you can use in order to build a machine learning model, but writing those algorithms from scratch on yourself by yourself is going to be really difficult. So using instead of that, what we do is we use Scikit Learn. Scikit Learn allows us to import the algorithms ourselves after understanding the data, and we can just use those algorithms that have already been pre-written for us to implement our model instead of us having to implement the algorithms ourselves. Since they are common algorithms, they have been implemented by people already. Okay, so now the thing that we have to understand is that it contains a lot of functions to perform commonly used operations. So it doesn't just contain the machine learning algorithms that we want to use. It also contains a few functions that we use a lot. So for instance, if we have some data set and we want to split it into a 70-30 ratio, it has a function for that. If you want to figure out if you want to validate our data set against different distributions of data, it has a function for that. If you want to generate a confusion matrix, it has a function for that as well. So there are a lot of things that it covers. It doesn't cover everything, but it has a lot of functionality out of the box that we can use. All right. So with that, I have another question for you guys. Hopefully, if I show it to you on the polls, you'll be able to see it. Okay. So now I think you can see the question. For those of you who are unaware, the question is, can you build a machine learning model by only using Scikit-learn and no other library? So if you are not using any other library other than Scikit-learn, can you build a machine learning model? When I say no other library, I mean you are not able to use Python as well you are not able to write, you are not using any other thing other than Scikit-learn. So for all the tasks involving machine learning and everything, can you use Scikit-learn only? So the answer that options that we have is yes and no. So I'll wait for the answers, and once I've gotten all the answers, I will tell you the correct answer. So I encourage everyone who's participating in the. All right, majority of you have answered, and the options that were available were yes and no. I'd like to tell you the correct answer, which is for the question that can you build a machine learning model with only using scikit-learn and no other library. The correct answer is yes, you can. Um, the people who have answered no, I'm assuming that you guys were thinking that because we have to use NumPy or Pandas or other libraries like that, we could probably not be able to use build a model without using those libraries. The thing is, you can build a model without using those libraries, but you would have to do a lot of coding yourself. You would have to import the data, parse it, uh, split it, and then use it inside the library of scikit-learn. But only using scikit-learn, you can build a machine learning model. It's just going to be really difficult, and without using scikit-learn on any library, it's going to be even more difficult. So the correct answer is yes. For those of you who have answered yes, you were correct. For those of you who answered no, you were incorrect. But depending on how your thought process went, you were really close. All right. So now let's move ahead. I've closed the poll, and now let's take a look at why should you use scikit-learn. First of all, it's very easy to use. Scikit-learn is extremely easy to learn and use, and it makes the task of implementing mathematical algorithms really easy because it contains all the implementation with it. We just have to understand how to use the classes and the functions available in the library. It's very well documented. It's got an extensive documentation that contains information about how to use every available feature in the scikit-learn library. And using that, we can take a look at that. Then it's been created by experts. So scikit-learn is a library that has been created by expert data scientists who have been inside the data science business for a long time. They have written these algorithms themselves, and these people have been writing algorithms that are relating to data science from their hand for a long time. So they know how to make a generic implementation that many people can use. And finally, it's very well tested. It's been used by several developers across the world who contribute patches and bug fixes. Scikit-learn is an open source library, so if you want to take a look at the code underneath the hood, you can just go to GitHub, search for scikit-learn or sklearn, and you can get the library code yourself. If you find some problem or want to help scikit-learn grow and add some features to it, you can use GitHub to add some features in the code that the scikit-learn has, and then suggest a revision to the developers and maintainers. Because it's open source, many people have already found a lot of bugs and submitted a lot of bugs. So that means it's battle tested as well, and it has seen a lot of issues already. Now let's take a look at steps in building a classifier. This is an important concept, right? So now let's take a look at steps in building a classifier. So there are 5 steps in building a classifier, but there are several steps in building a classifier. 5 to be exact, but depending on how you're training a model, it could be more and could be less. Usually, these are the 5 generic steps that are used. The first thing is we import the library. So if you're using sklearn, NumPy, Pandas, you import it. Many people import it throughout their code. So as soon as they need something, only then they'll import it. I like to import everything at the top of my file so that everyone who's using my application knows, or looking at the code that I've written, knows what are the libraries that my code depends on. So you can firstly import all the libraries needed to train and build the model that you need. And these libraries can perform tasks ranging from numerical manipulations, such as NumPy, and testing the accuracy that we'll be using scikit-learn for. All right. And then what we do is we import the data set. So data set is the data that we will be training our model on. It's important to understand what data set we'll be using and how we'll be using it. So that's how we firstly need to import the data set, or we can, after importing the data set, we view the data set, we load it, we manipulate it so that it's clean and it's in a state that we can use it to train our model and do the following steps. And after that, we can use it in machine learning models. After that, what we do is split the data. So when we get the data set, its X and Y variables are right with each other. So the thing that we are using to make the prediction and the prediction itself are right inside the data. First we split that, and then we split our data into a training and testing set. Training set is used to train the model, testing set is used to test the model, and using that we understand what is the how the model has learned and what is the accuracy that it's giving us. Then comes training the model, in which is the task of the Scikit Learn library. It creates an algorithm and allows us to feed it data so that it can learn from the data. And after learning from the data, it can do the classification or regression tasks that are needed. Finally, we test the model. We give it the data that we had set aside for testing. After giving it the data, we ask it to make the classifications, and depending on how many were correctly classified, we give it a percentage from 0 to 100. Higher percentage means our model is more accurate, lower percentages mean it's less accurate. What is the max percentage of a model accuracy? The max percentage is 100%, but no model can be expected to have 100% accuracy. If your model, when training or testing, it gives 100% accuracy, it could be that your training set is too small. That is, it either contains only 10, 20, 40, or 100 values, or it could be that your training set is overfitted, which is the variance issue that we have talked about recently. So you need to train your model again, and if it sees some data that it hasn't already seen, it will give poor results. Someone has asked is some more detail on splitting the data set and why and how. So splitting the data set is basically the task when we get the data and we want to set aside some data that our model can be trained on, and the remaining data is used to test whether or not our model is giving us correct accuracy. So as in supervised learning, we already have the data and the output that it should map to. Once we feed in the data and we take a look at the predicted output and the correct output, the percentage of outputs that match are the ones that are correctly classified, and the ones that are correctly classified are the outputs that lead to higher percentage of accuracy. So someone has asked to explain some example on training the model. Training the model basically means just taking the algorithm from the Scikit Learn library, feeding in the data, which is the x and y variables that we have splitted for training. Then that data, that algorithm learns from the data, and after that we can make predictions using it. We'll take a look at that in the demo. All right, hopefully you can see the question. The question, yeah. So the question is, which set is used to validate the performance of the trained model? So once the model has been trained, which set is used to check whether or not our model's accuracy is good? So I'll wait for a few moments and you guys can answer in the poll and submit your answers. Whether it's training set or testing set. Training set is the first option. Testing set is the second option. Alright, in the meantime, people have asked a few questions. I'd like to answer those. Someone has asked, what is the ratio to split the training and testing set? So for training and testing, you can split the data into, depending on how large your data set is. If it's really large, like you have millions or billions of rows, then you can just take 1% or 10% of your data. If it's a small data set, then 70-30 is a good ratio to split your data on. It's testing set, which is the correct answer. The training set is used to train the model. The testing set is used to figure out whether or not the answer is whether or not the model is performing well, which is why we use it. And let's have our hands on. We'll have a demo here. So I already have prepared a Jupyter notebook for you guys, in which we perform all the 5 steps. So let me just first explain what we're doing. We're using the iris dataset that contains information about flowers. It contains information about the sepal length of a flower, sepal width of the flower, petal length of the flower, and petal width of the flower. Using these 4 features, we're trying to predict the kind of flower that it contains, or kind of the iris flower that it's containing. There are 4 kinds of flowers that our dataset has. 3 kinds of flowers that it has: Virginica, Setosa, and these are the different kinds. So what you do is, firstly we import all the libraries. As you can see, the libraries were easily imported, so it works fine. And from sklearn, I'm importing the load iris function that will get us the dataset. It's a very common dataset, and so that you can follow along with me and you don't have to wait to load the data from some remote data source, you can just use this code that I'm showing you on my screen right now. And then we are using the train test split function, which we'll use to split our data set into the specified ratio. Someone has asked, can we try it on Google Colab? Yes, you can try it on Google Colab. That's a very good use case for Google Colab actually. So if you want to use Google Colabs, or if you want to use your local notebooks, you can use those as well. Okay. With that, we have train test split, which is the function that is used to split the data. We'll be using the logistic regression model, which we can import from sklearn.linear model. And finally, we will be taking a look at the accuracy score as well. And Scikit-learn already gives us a function that does it for us. I'll be more than happy to answer you on the questions that you ask about the code that you're watching. If you want to follow along, you can type in the code in your Jupyter notebooks if you have it. If you don't have Jupyter notebook, then it's going to be difficult for you. You can use Google Colabs. That's a really good option for you to try if you want to follow along. So now let's take a look at it. So someone has asked that they need to import the data set. Should they need to import it with its name? So we are using the load iris function, and using that you can just import it. You don't need to specify any name. If you have a CSV file on your local system, you importing that you would need pandas library and need to know the file and the example. Okay, so now we load the data set. But now let's take a look at what the shape of the data set is. As you can see, it's a dictionary. Dictionary is a key value pair. It's a common Python data structure. It contains a key of data that contains all the data, and it's 5.1, 3.5, 1.4, 0.2. These are individual rows in our data set. Now, we don't know what these values mean. So taking a look at the data, we have targets as well. Targets ranging from 0, 1, and 2. Now let's take a look at the target name. These are the different types of flowers that we'll be predicting. These are the categories that we'll be predicting. Setosa, versicolor, and virginica. So 0 means Setosa, 1 means versicolor, 2 means virginica. The reason why we have encoded them into numbers is because machine learning algorithms only understand numbers. They don't understand words or strings or letters or sentences. So we need to first convert those numbers into letters in classes into numbers, and then we can make the prediction. And now for our columns, we want to be able to understand what are the different columns that we have. And what we get here is we get the sepal length, sepal width, petal length, and petal width. So it's given us the example of what we have. So feature names are: the first column has sepal length, second column has sepal width, third column has petal length, fourth column has petal width, and all of them are in centimeters. So that helps us understand the data. Now it's time to split the data. We'll split it in X and Y. We'll be using these features, these features, and using those, we'll be predicting these targets 0, 1, or 2, which map to Setosa, versicolor, or virginica. So with that, after splitting the data, I try to split it into 70-30 ratio. So let me just explain what that means. Using the data set that we have, the data.data, the data key inside it contains all the data that we need. So let me just show you what the size of the data is. If I insert a row below and look at the length of X, we have 150 rows there. Now if I split it into a 70-30 ratio, right? And now if I insert a row and I print the length of X train, we have 105. So 70% of 150 is 105, and remaining 45 are for testing. So we will use 70% of our data for training, 30% for testing. And with that, we create a logistic regression model. This is a class in sklearn. It just takes in the logistic regression model and creates an object of it. We use the fit method to fit our data. Fit basically means train our data. We pass in the training X variable and training Y variable. So the 105 rows that we have created for testing, we pass it inside our training and testing set. If you're following along, if you want me to scroll up to help you look at the code, this is what the first line, first things we import is. Then we load the data set. You only need to write this code. This is just for explanation. This is markdown format, so you don't need to copy that. After we have trained our data, since our data set is small, it trains in a few milliseconds. Now we make the predictions. And after the predictions are made, we take a look at the accuracy, and accuracy is 88%, which is quite good. Because machine learning models use statistics, these accuracies could change. So if I train it again and then I check it again, it's giving me 100% accuracy because our data set is too small, and now it's giving me 91% accuracy. So it's giving us high accuracy, but the accuracy is variable. The reason why is because depending on how data is split. When we split the data using train test split, it splits it randomly. So it takes a look at 45 values randomly and splits it into another 45 and 105 random values from the entire data set, and then we can train the model. So someone has asked, is face recognition classification or face recognition is a supervised learning problem. It's a classification problem, but it takes a look at very different technologies that are not just part of classification. It takes a look at computer vision, handling the data. There are many other different kinds of things. Face detection is a classification algorithm. Face recognition is a system that uses classification algorithms along with other algorithms as well. Is computer vision an area of ML? Yes, it is. Thank you so much for joining me, and hopefully this has been informative.